Good afternoon. Today we are going to start the paper number 4, Analytical Chemistry. The analytical is the fourth paper in your TY basic course. First is physical, second one is inorganic, then organic. After that is fourth paper is analytical chemistry. So this course has 6 chapters. The first chapter of the course is gravimetric analysis. Second chapter is thermal method of analysis. After that, the third one is spectrophotometry, and fourth chapter is polarography. Fifth one is atomic absorption spectroscopy, and last one is flame emission spectroscopy. Basically, the name of course is analytical chemistry. So in that course we going to understand the different kind of techniques which are used to analyze the components, analyze the sample or analyze the matter. So we have the different types of matter: solid, liquid, gaseous state, in a composition state. So every composition, every substance has been analyzed using the different kind of techniques, and in that course we are going to learn, we are going to understand which techniques we can use to analyze the particular type of substance. So there are almost more than 20 spectroscopic techniques are used, and you all know when we are going to analyze any substance, that time we have used two methods. First method is we use chemical method. So using different chemical reactions we can determine the chemical properties of the substances or chemical property of the components. But when we going to discuss, when we going to know the structure of the unknown sample, unknown component, that time we use physical method and as well as chemical method. So physical method means what? There are different kind of spectroscopic techniques are used when any sample is in contact with radiation, different kind of radiation, and you know in the spectrum there are different radiations are used: X-ray, gamma ray, then radio waves, IR, UV rays, NMR means radio frequencies, okay, cosmic rays are used. So different kind of radiation, X-ray, so different kind of radiation used to elucidation the structure of the component. Okay, so based on that different kind of radiations, different kind of principles, the different spectroscopic techniques or different analytical techniques was introduced, was discovered, and that techniques helpful to us to know number of parameters about the unknown sample. Okay, so in first chapter there is a gravimetric analysis, and in thermal analysis we are going to discuss how to know it is a quantitative analysis. Quantitative means we determine the quantity of the unknown sample which is present in any process. So to know the weight we use gravimetric analysis in the presence of high temperature condition, same as a thermal condition also use. Third chapter is very important to know the spectroscopic technique we use to know the samples, to know the component present in unknown samples. Polarography also same kind of technique which is used for different type of or a special type of components to know their number of parameters. Flame emission and atomic absorption, again there are remaining techniques we are going to discuss given in that course. So today we are going to start the chapter number 4. First 3 chapter will taken by Dushing sir, and chapter number 4, 5 and 6 I am going to taking here. So first is polarography. Okay, and in polarography there is a first point is introduction. So polarography technique was discovered by Heroski in 1925, and due to his work he won the Nobel Award in 1952. So this technique, it is a branch of chemistry and it is considered as a voltammetry. It is a branch of voltammetry. Voltammetry means it is related to the current which is present, current and potential relationship in that technique. Okay, so here when the potential is applied on the one of the electrode, when the current is passed, That time to measure this potential when current is passed on particular electrode. So in any cell, in any technique, suppose two electrodes are used, and when two electrodes are used, one of the electrode we going to measure the potential on that electrode when current is passed. ज्यावेळेस करंट पास होणार आहे एका सर्किटमध्ये, ज्यावेळेस दोन इलेक्ट्रोड असतात त्यावेळेस एका इलेक्ट्रोडवरचं पोटेन्शियल डिटरमाइन करायचो आपण, त्याला म्हणतात व्होल्टॅमेट्री. To determine the voltage, to determine the potential, because potential always measured in the electron volt. So that's why it is a branch of voltammetry, because we will determine the potential. Basically the polarography technique used to that kind of substances which are undergoes reduction and oxidation. So reducible and oxidizable substances when undergoes their processes, means one of the substance which undergoes the oxidation, so that time loss of electron, so that time oxidation potential is there. When any substance which undergoes reduction, that time reduction potential is there. So we measure that potential when current is applied. So current is passed through that circuit when substance is analyzed. That time how much potential is developed or on the one of the electrode we are going to discuss, we are going to measure it. That's why it is a branch of voltammetry. Okay, so basically in that technique two electrodes are used. One of the electrode in that technique has their larger surface area, it is a macro electrode, and second one is the electrode which having the smaller surface area, it is a micro electrode. So micro electrode and micro electrode, there are two electrodes are used. Micro electrode basically here use of pull of mercury, sometimes use of saturated calomel electrode. So these are the micro electrode because their surface area is large and they are non-polarizable. There are non-polarizable, but the substances which are easily, or is the substances which are smaller surface area, there is a micro electrode, these are polarizable, they are easily polarizable. That means here we use the dropping mercury electrode as a micro electrode, and we use the pull of mercury, or we can use the saturated calomel electrode as a larger surface area. So basically in introduction point, it is the branch of voltammetry. Here we are going to measure the potential apply on the one electrode when it pass through the, when current is passing. Okay, here two electrodes are used. One of the electrode is micro electrode which has the smaller surface area. Another electrode is larger electrode, large surface area electrode, it is a micro electrode. And the micro electrode means we can use the pull of mercury, or sometime we can use the saturated calomel electrode as a micro electrode because surface area is larger. But here it is the diagram of dropping mercury electrode. This is the functioning of how dropping mercury electrode is used. This is the diagram, and we will going to discuss their function, how it work. Okay, so in introductory point, very important point is there are two electrodes are used, larger surface area and smaller surface area. Large surface area means micro electrode. The example is saturated calomel electrode or pull of mercury. That means it is sometimes called as reference electrode. Okay, and second one is the indicator electrode. Working electrode means the example is dropping mercury electrode. Pull of mercury means what? Just there is a liquid, or there is a just mercury is given in that between the electrode, two electrodes. Okay, suppose here is the one electrode, here is the solution which is taken to be analyzed. So here the dropping mercury electrode is used, pull of mercury is used, or sometime another electrode is placed here which is the calomel electrode. So dropping mercury electrode, second is the calomel electrode. We are going to discuss in the principle. Okay, so it is all about the introduction. So it is there are two electrodes, one is smaller surface area and here is the larger surface area. Smaller surface area is a polarizable electrode and non-polarizable. So it is just introduction. Second point is principle. In going to discuss the principle, how this technique is used, which principle is behind or introduced in that technique. So the principle says there are two electrodes are used. One electrode is reference electrode. Second electrode is indicator electrode. So reference electrode means what? The electrode which having the larger surface area. Secondly, it is the non-polarizable, and the example of reference electrode is saturated calomel electrode or pool of mercury which is used. The surface electrode acts as a anode, it is the positively charged, and second one the indicator electrode, that means the electrode which having the small surface area and it is the polarizable, it is the polarizable, and the example of indicator electrode is dropping mercury electrode, dropping mercury electrode, and this dropping mercury electrode acts as a negatively charged, that means acts as a cathode. So there are two electrodes which is used, and when any solution which is taken for the analysis, that solution is put or insert or placed between that two electrons. Which electrode? One is reference electrode, another is indicator electrode. So indicator electron is very important, because it depends on indicator electron we can measure the potential, because the potential which is developed between this when current is passed, because of the solution which is taken for the analysis is the electrolyte solution, because which having the electrolyte conditions. So that time when current is passed, that time the solution containing either oxidizable substance or reducible substance. Okay. If oxidizable substance is there, it undergoes oxidation, it undergoes loss of electron. So if loss of electrons happen, that time there is a cathode, there is an anode. So the negatively charged particles means here mercury is present, we are going to discuss in detail. So when mercury drops comes here, it acts as an anode, they attract with the cathode, they attract towards the calomel electrode or they attract towards the pool of mercury other. So that time how much potential is applied, how much potential is developed when this substance undergoes oxidation or reduction if current is passed. So that time the potential developed on this electrode, on the dropping mercury electrode, we are going to measure it and find the potential is the voltammetry technique, is the polarography technique. So there are series of substances we can use, series of substances we can analyze and measure their potential at the time interval or at the time dependent. But basically here how much potential is developed, how much potential is produced when current is applied is depends on the concentration of the solution, means how much concentration of solution taken to be analyzed, that will shows the how much potential developed on the electrode, and on which electrode the potential is developed, on the dropping mercury electrode. So it is all about the introduction. So basically the potential which is developed is based on concentration and nature of the substance. Nature means what? You know the concentration. Suppose one substance has 0.1 molar concentration and another has 0.2. So 0.1 and 0.2, there is a different potential is developed because both has different concentration, different number of ions are there. If different number of ions are there, so they has different potential developed on the dropping mercury electrode. We are going to analyze, we are going to measure it. Okay. So nature means what? Basically two types of substances considered here. One is oxidizable substance, another is reducible substance. So oxidizable substance lost the electron, reducible substance gain the electron, and which and they develop the potential, oxidation potential and reduction potential. We are going to measure using the polarography technique. Second, the point is dropping mercury electrode. So this is the diagram of dropping mercury electrode. Here is the mercury reservoir. Here is the mercury which is placed. The capacity of mercury reservoir is 100 ml. Here is a flexible tube which is attached to this This container, this vessel, or it is a cone, it depends, it is a round bottom flask is there, so it is attached here, flexible tube is here, and here glass tube is attached which containing the capillary. So here is a glass capillary tube is there. The length of this tube is 7 centimeter in a length, and the diameter is near about 0.5 millimeter is the diameter. Here is uh, the flask which containing the analyte means is the substance which is going to analysis. So analyte is here, with that this reference electrode is present. It may be calomel electrode, saturated calomel electrode, or it is the pool of the mercury. Okay, it acts as a, here is the positively charged, means here is the anode substance is there, here is the cathode, the circuit is attached, the current is applied. When current is applied, that time the mercury drops are travel here through this capillary, and one by one droplets comes, because the droplets containing negatively charged, and negatively charged attract with this opposite electrode, means it is an anode. So that time how much potential is developed here will measure by this method. So when current is applied, the drops comes one by one. When drops are comes on the surface of pool of mercury, that time the potential is measured. How much potential? So basically when drop comes, their lifetime is 3 to 7 seconds. The drop lifetime is 3 to 7 seconds. One drop come, second drop. So always when drop comes here, it is neutralized here and it goes into the other part, means if there is a pool of mercury is used, it comes there. So this way it is a renewed. The droplets of mercury renewed and reused continuously. That's why the technique is more efficient to determine the or to measure the potential which is produced during the oxidation or reducing. But there is an important drawbacks we're going to discuss in next part. So here is the capillary, this is the very important. So two parts are considered here. One is mercury reservoir. So when we going to actual perform this experiment, this height should be kept constant, because here is a capillary. So if we change the position of this reservoir, we can make the errors. So that's why, because the lifetime of droplets are continuously, here is a drop comes here, the drops containing negatively charged, the negatively charged drops attract with the calomel electrode or with the pool of mercury, and here is the analytic solution is given. Sometimes KCl is add, number of other substances are, it is a detailed part. But when the drops comes which is negatively charged, it attract with anode, that time we measure the potential. त्यावेळेस आपण काय करतो, पोटेन्शियल मेजर करतो. म्हणून याची जी पोझिशन असेल ही परमनंटली कॉन्स्टंट असते, ही पोझिशन चेंज करायची नाही जोपर्यंत आपण त्याचं ॲनालिसिस कंप्लीट करत नाही. सेकंड, कॅपिलरी ट्यूब containing, there is a 7 meter in length, 0.5 meter in diameter. So here is it is a narrow, okay, it is a very narrow at the end. So that's why the drop comes from this is uniform. म्हणजे प्रत्येक वेळी जो ड्रॉप येणार आहे त्याची साईज सेम असणार आहे. सो सेम साईज असणार आहे. इट इज निगेटिव्हली चार्ज बिकॉज निगेटिव्ह करंट is there, it acts as a cathode, so negatively terminal, here is a positive terminal. मग हे हा ड्रॉप इथं अट्रॅक्ट होणार, त्यावेळेस इथं जे पोटेन्शियल डेव्हलप झालंय हे पोटेन्शियल मेजर करता येतं, कारण की करंट आपण इथून पास करतो. दोघांना करंटने सर्किटला हे काय असणार आहे, दोघे इलेक्ट्रोड्स अटॅच असणार आहे त्या इन्स्ट्रुमेंटला. सो दिस वे वी कॅन कॅल्क्युलेट दी potential which is developed in oxidation and reduction reactions. So it is all about the, and dropping mercury electrode called as working electrode, called as functioning electrode, or it is the micro electrode. So working electrode, and this one is the reference electrode. So working and reference, or it is an indicator electrode. Okay, so this is all about the dropping mercury electrode. So this technique has some advantages and some disadvantages. So first advantage is the mercury is very smooth because mercury is in liquid state, and it is a continuously, shows a continuously and constant flow. Secondly, it is renewed and the surface area is reproducible, or surface area is reproducible means here is the surface of mercury, this surface area again reproducible. That means it is the advantage of this technique. Second, the mercury form amalgams. When one of the metal components are given, suppose sodium is used, and you know sodium plus mercury, they form metal amalgams with each other. Suppose we use aluminium, so aluminium mercury attached together form we called as amalgam. So when any mercury which form the component or composition with the metal, we call it amalgams. त्याला आपण काय म्हणतो amalgams. Okay. Now after that, mercury has high hydrogen over voltage. Then the surface area of mercury drops can be calculated from the weight of drop. Means how much surface area? The surface area is calculated of this mercury drop by their weight. It is an advantage. Second, the electrode is continuously renewed, and this electrode is continuously renewed. Again regenerate. Once first drop is comes out, again second drop comes after that, so again it acts as a electrode. So it is a renewed electrode. त्याला आपण काय म्हणतो renewed electrode. तो पुन्हा पुन्हा नवीन तयार होत असतो, म्हणून त्याला आपण म्हणतो renewed electrode. कारण की एक ड्रॉप गेला, परत दुसरा ड्रॉप येणार, परत इट्स acts as a electrode, इट्स acts as a cathode. So it acts as a continuously new electrode. एक ड्रॉप गेल्यानंतर दुसरा ड्रॉप आला का तो न्यू तयार होतो, परत न्यू इलेक्ट्रोड म्हणून काम करतो, म्हणून त्याला म्हणतात renewed electrode. It is an application, important advantage. The diffusion current is assumed by the steady value. So diffusion current means solution is here and their diffusion current we can measure, or we can assume this technique. It is an advantage, another advantage. Then it can be used over the range of plus 0.4 to minus 0.2 volt. It is used in which range? Plus 0.4 to minus 0.2 volt. So only in given range we can calculate the potential. Suppose any substance which has a potential above this or below this, we cannot be measure. It is the drawback. हा त्याचा काय असणार आहे? ड्रॉबॅक असणार आहे, कारण की आपण हे जे रेंज असेल प्लस 0.4 टू मायनस 0.2 व्होल्ट, ह्या रेंजमध्येच आपण काय करू शकतो, पोटेन्शियल मेजर करू शकतो. अदरवाइज above and below this range we cannot be measure it. So it is the drawback of or disadvantage. So there are disadvantage. The area of microelectrode changes as the size of drop change. When, if, what is the disadvantage? If there is a something, the levels are changed, positions are changed, the drop comes here, their size may be changed. If size is changed, the surface area change, and if surface area change, it makes the error in a potential which is measured. So this is a disadvantage. Again, we only measure the potential between plus 0.4 to minus 0.2 volt. Below or above this range, we cannot be measure the potential of substances. It is the another disadvantage. Secondly, mercury is highly poisonous. So there it handled with carefully. It is very important. That's why again this is the disadvantage of mercury, dropping mercury electrode or using this technique. After that, mercury is easily oxidizable. It easily oxidize, and that's why only reducible substances can be measured. We can only measure mostly the potential of reducible substances, because the dropping or because of mercury itself undergoes reduction, oxidation easily. So sometime we can measure the potential of that substances which are reducible or that substances which are highly oxidizable. So in that, here in a electrolyte condition, if we place the solution here, the oxygen also present with that. So that's why the nitrogen gas pass through this chamber. So nitrogen is more heavier than the oxygen. Suppose oxygen is here, if we pass the nitrogen, so nitrogen taking place of oxygen, because oxygen is lighter and nitrogen is heavier. So nitrogen comes here and oxygen is out from this analytic position, or from the analyte, from the solution. So it avoid the oxidation of mercury. जर ऑक्सिजन तिथं असेल तर ऑक्सिडेशन होऊन जाईल मर्क्युरीचं, ते होऊ नये किंवा व्हायला नको म्हणून आपण काय यूज करतो की नायट्रोजन गॅस पास करतो. नायट्रोजन गॅस जर पास केला तर इथून जो ऑक्सिजन होता ऑलरेडी प्रेझेंट तो रिमूव्ह होईल, म्हणजेच ते ऑक्सिडेशन आपण अवॉइड करू शकतो. सो दीज आर द some important disadvantages of this technique. So we stop here. In next lecture we are going to discuss the instrumentation of the polarography. So basically important point is when we perform this we just measure the relationship between the current and voltage. It is we measure the relationship between voltage and current. So we plot the graph against it. The graph called as polarogram means it indicates there is a relation between the voltage and current, means it is a potential. Okay, so how much current is applied and how much potential is produced on the electrode, that will plotted on the graph. So this is a relation between the current and voltage. So this is the polarogram. त्याला आपण काय म्हणतो polarogram, and the instrument which is used to measure this polarogram is a polarograph. Polarogram, polarograph, and technique called as polarography. Techniqueला काय म्हणतो आपण polarography. So is the polarogram, the instrumentला म्हणतात polarograph, and the technique is called as polarography. So this is all about the today's lecture: introduction, principle, and the dropping mercury electrode. So in next lecture we are going to discuss the instrumentation of the polarograph, how instrumentation they design and their different function, working, construction and working we are going to discuss in later chapter. So we stop here.